The next questions, we are going to look at number 3 from your 12.2. This is the video 3 of 12.2. They give you a function. They want to find the location where the function is concave up and concave down, and then where's the inflections point. So again, for concavity, we need to find the second derivative. So go ahead and find the first one and the second one. If you need to pause the video, go ahead and do that, please. So to check this with you, look like this one is a chain rule, and the 2 is going to turn into 0, right? So let's see. The chain rule say we bring down the exponents 3, and then x minus 1, just subtract 1 from the exponents, and then multiply to the inside part taking the derivative, right? So that will turn into, this one is 1, this one is 0. It's going to be just 3 times x minus 1 to the second power, right? Because it's multiplying to a 1 minus 0. Okay, so that's your first derivative. Using that, if I take the derivative one more time, so it would be 3 times 2, right, equal to 6. And then x minus 1 will turn into 1 less than this degree, so 1. And then take the derivative of inside part, so it's going to be x minus 1 derivative again, right? So again, this thing is going to turn into 1, so it's going to be 6 times x minus 1. So if that's your second derivative, then to find the critical number for this guy, we're going to need to set the second derivative equal to 0, right? So I have 6 times x minus 1 equal to 0, or you can say 6x minus 6 equal to 0. This will give me 6x equal to 6, right? And x will equal to 1. Okay, so this number we can use as a boundary point to set table. Number line and table. Okay, so if I have x equal to 1 here, and this is negative infinitive, this is positive infinitive, right? Then I will have negative infinitive to 1 and 1 to infinitive, right? Because we are checking the concavity, so we're going to plug in second derivative. So f double prime of a number, f double prime of a number. So pick a number in here. It could be 0 is the easiest one. And then we can plug in maybe 2. So if we plug in the second derivative, that means we're going to have 6 times 0 minus 1, which would be negative 6, which is a negative, right? And then we plug in 6 times 2 minus 1. That would be 6 times 1 equal to 6. So that's a positive. So when you plug in the number to test and its second derivative, negative means concave down, like a frowny face, right? If it's positive, means concave up. So, and x equal to 1 will be my inflections point, right? So I can go ahead and write that. Concave down is between negative infinitive to 1. Concave up is between 1 to infinitive. And for the inflections point, it's going to be x equal to 1. If I need to find the y value, where should I plug in? Good. So it's going to be on the actual function. So plug in 1, we have 1 minus 1 cubed plus 2. So it's just 0 plus 2 equal to 2. So the inflections point is going to be x equal to 1, y equal to 2. Are we okay? So there you go.